Yeah, so good evening, guys. Yeah, welcome to our first session of Flutter Wednesdays. Yeah, we had recently started with the installation, but that wasn't part of the series. So the series starts today. I'm Alex Moniki. I'm the GDSC Cybersecurity Lead, University of Embu. And so we have Victor, who is going to take us through this session. Victor is the Flutter Lead, the Dan Kimathi University of Technology. Yeah, so he's going to take us through that programming, which we'll cover that in our first series, which is today. Yeah, so on to you, Victor.
Uh, okay, thank you so much, Alex. And once again, welcome you all to this wonderful session. We will be looking at that very versatile and a wonderful programming language, which amongst its many uses is the Flutter framework. Like that is mainly known for the Flutter framework, and it is like okay, Flutter is one of the most upcoming programming uh, frameworks for building highly performant applications for both mobile, desktop, and I think yeah, and also web platforms. And it is very important to at least have some that knowledge before you get into Flutter. And that is what we are going to look at today. Oh, okay. I forgot to say my name. I am Victor. I am the GDSC lead at the Dan Kimathi University of Technology, and I humbly and very grateful to welcome you to this session. I hope you will learn something, a thing or two about that, and yeah, so that your Flutter journey will not be with so much hindrances. Alex, I think, can you confirm if my screen is visible, like the screen share
Yeah,
slide?
your screen is visible. It's all clear.
Okay, thank you. There is a session we had with GDSC Embu about Flutter, and we talked more about Flutter. We explored its strengths, and just as a recap, I think I'll go through Flutter again just a little bit. So if you want to know more about Flutter, you come to this website, flutter.dev. Flutter.dev, you just type flutter.dev, and you'll see this amazing homepage. Let me zoom in just a little bit. Yeah. So this one, and the tagline is "Build for any screen." So what Flutter basically is, it's like a UI framework that helps you build applications for different types of devices, that is operating systems. For mobile, we have mainly Android, that is the Android apps and iOS apps. And then we have the desktop platforms, that is the Windows, Linux, and Mac OS. Then we also have wearables, that is the Watch OS, I think, uh, and also the web, that is you can build web apps with Flutter. So that is what is indicated here. You can see like this is an iOS phone, this is an Android phone, this is on a web platform, and yeah, you can see these beautiful UI screens built here. Uh, they ca- there is this description over here. We went through this description over here where we said Flutter is an open source framework by Google for building beautiful, natively compiled multi-platform applications from a single code base. We defined all of these terms. We were said that like of open source is the source code for Flutter is open on GitHub. Like anyone can access it. Anyone on the internet can access the source code for Flutter. That means it is easier for developers themselves as they interact with the framework to raise issues to the Google team for changes, improvements, optimizations, and all those stuff, and also features to be added to Flutter, uh, which makes it a really growing framework by Google. Uh, so that is the meaning of open source. It is open. Everything is done on the open. And then, of course, beautiful applications, as you have seen above. Then we have natively compiled. Natively compiled means it recompiles to the platform direct. Like if you are running a Flutter app on Android, it compiles to Android direct. If it is iOS, the same. For web, it compiles to JS like directly. This makes it a little bit faster compared to its competitors, like the other cross-platform technologies like React Native, which maybe uses a bridge. Like you write your code, then there is a bridge that compiles it, and then it sends it to to different platforms. For Flutter, it is directly natively compiled, and it makes Flutter faster. Then we have multi-platform. As you have said, you just write a single code base and you run that in your iOS. The same code base you run on your Android, the same code base you run on your web, and all those platforms. So yeah, so that you can be able to build Flutter applications, you need Dart, the one that we are exploring today. And Dart is the programming language. Flutter is just a framework. The difference is that Dart uh, that as itself it is a programming language just like any other programming languages. For example, we have languages like Python, JavaScript, C++, then Dart. You cannot put Flutter in the list of programming languages because Flutter itself is not a programming language, but a framework. So what a framework does is that it gives us tools, the tools that we use to now come up with mobile applications, tools like widget analyzers, the performance optimization tools, tools to compile APKs, tools to compile web code, that is. But the programming language behind Flutter is Dart, this one. And that is now what we are going to learn today. You cannot like be well uh, conversant with Flutter if you skip learning that, you see. Yeah, so again, before we continue, like if you have any question or any query, you can just type it in the chat, then I'll be looking at it periodically. Yeah, thank you. So I think we can now start with that. Up to there, I hope there are not any questions. I'm sorry. Yeah. So that, let me slide show this. Okay, so having said all that, what is Dart? So Dart is an open source general purpose programming language. It was developed by Google. It is used for building web, mobile, and desktop applications. We have seen that Dart is the parent programming language for Flutter. So it is the programming language behind the Flutter framework because, okay, Flutter makes Dart famous. Like most of the people actually think that, uh, like most of the people do not know, do not differentiate Flutter from Dart. Yeah, but that is the programming language. You can use that for other purposes other than Flutter. You see, like you can use that on low-level devices. That is the IoT devices. You can use that for building web. I think web backends. There was a framework for that, but I don't think it is functional up to now. So that can exist on its own, but the most common use of it is Flutter as a framework, and it was also developed by Google, and it is the primary language for developing Flutter apps. Yeah, so why that? Like the strengths of that and why choose that? So the first thing is that it is strongly typed. This helps with code reliability. The meaning of strongly typed, okay, I think it is it is good if I just demonstrate this with the actual Dart code. So I'll just bring up VS Code over here. So just for the basics of programming, there is when you create a Dart file, okay, when you install Flutter in your system, which we did in the last session, that comes inbuilt with it. So you can just create a hello.dat file without creating a Flutter project. If you installed Flutter in your system, that also comes together. Like the moment you download Flutter, you also install that in your system. So you can just create a .dat file and run its commands independently without creating a Flutter project. So I have created this hello.dat file, and we will be using this for our for the purposes of this session. So we are saying that that is strongly typed. The meaning of strongly typed is that that does not allow you to assign values of different data types in one variable. For example, you have I know like we have not reached here, but I'll just show. So final, let me illustrate with final int age. Let's say we are defining some age is equals to 20 or 30, like that. So the moment that you have specified that this is an integer and you have given it some value, you cannot down here come and initialize this age again with a value of a different data type. For example, let me do final. Okay, let me omit this final for the purposes of reinitialization. So final age is equals to, and then you give some string. It will say that this age cannot be given some string because it is already assigned to some integer. So if you have interacted with other programming languages like Python or I think JavaScript, yeah, you will see that you can assign a value of type integer and then up a chain, like down below or some lines after that, you can reassign that value with a different data type. For our case, this is a string. Let's say this is a string. Yeah, this is a string. So you cannot assign this age to an integer. That already knows that this is an integer, so you cannot give another data type to that variable. Don't worry about these variables, we'll come back to them later. But the nature of that being strongly typed, it helps it a lot, like in terms of how you write your code and in terms of avoiding bugs in your code. And then it supports asynchronous programming for efficient handling of operations. Asynchronous programming is whereby, like, if you have some operations that are taking long to execute, the other parts of the code just continue running until when those pending operations are done, they will then be executed like alongside your code. Like it does not wait for everything to happen at the same time. So it supports waiting for some operations to go on, and then later when they are done, you continue with your main operations. We'll also see an example of this asynchronous programming. Then that offers just-in-time and ahead-of-time compilation. This means that when you are writing that code in your IDE, Kama VS Code, like for instance, VS Code, the just-in-time nature happens when you just run that code, there is some compilation that happens that time. That is when you hit that compile button, that is just in time. But also there is this ahead of time compilation. This is like, for example, for the case of strongly typed, like when you are saying it is strongly typed, what helps it determine that this value was given to this variable at this with this specific type. This is ahead of time compilation. It checks through your code and tells you that some lines above you initialize this variable with a different data type. Like if it is like that age, you had given it an integer. Then a couple lines below it, you're giving it a string. you see. So it will just warn you beforehand, before you just compile it, and then you'll get the errors later. So this really gives that a strong preference, especially with dealing with Flutter, because you don't want you to discover bugs in your application after you have done writing it. It also helps the developer to eliminate these errors before even building the application. So it helps a lot with that. Also, gentle learning curve. If you have interacted with any other programming language, you'll find that so much easy, especially if you've done some C or C++. The syntax is close to that. Also, the people who have done JavaScript for maybe web or stuff, you'll see that that will be a smooth sail for you to understand. Yeah. The next slide is the Dart syntax. So Dart uses the C style syntax, which makes it familiar to many developers. It is a case-sensitive language. By case-sensitive means if you declare something with, let's say, the age that you saw earlier, with a capital A for age, and then down some couple lines down, you declare another variable called age, but that time you give it a small a, that will be a different variable. Like it is case sensitive. If it is block letters, it is block letters. If it is small letters, you just use that. You just use that consistently. And then it uses semicolons to terminate statements. Yeah. So at the end of the code statement, you have a semicolon. Other languages like Python, they use a line end, like a line break. If you write code on one line, and then if you want to start another statement, you just click enter, and that is a new statement. But that will follow until where you have your semicolon. That is where the code breaks to the next statement. Yeah. I hope there is no question up to that point. Maybe you can confirm if we are still together. Yeah. Kindly send me the WhatsApp group link to join. So the link will be sent by Alex. Alex, I think you can send the link here. Okay, the chat. Yeah. You'll definitely get the slides after this. Okay, yeah. I hope we are clear up to that point. Yeah, I will continue. So the next thing is now we come to the variables and data types. And yeah, so declare variables using the final keyword or const keyword. The common data types include the integer, double, string, and bool, just like most or any other programming languages. The type inference that automatically deduces the data type. So I think this will be better if illustrated. So I'll bring up my VS Code over here, like that. And don't worry about this. I think yeah. So before we start writing any Dart code, any Dart code that you want to run anywhere, may it be in Flutter or with this just a Dart file, the code you want must run inside a main function. I think this is similar with C or C++. Also, what other programming language? Golang also has the func main function, similar to that. So we have void main, just like that, nice and easy. So this is, let me increase the font size of this just a little bit. I'll make this 23. I hope this is visible. Let me make it 25. Yeah. So any Dart code that you write or any Flutter code that you write, there must always be a void main. And inside this void main, this is where everything happens. If it's your functions you write outside this code, you must call them inside void main for them to be executed. So So inside this void main is where we will be writing our code. Let me just, yeah, just like that. So we are saying there are various data types in Flutter, and in that, and the common ones are int, double, string, and bool. So if you want to write a data type, you just use the final keyword, that is final, and then you give the data type of that data. For example, let's say string. We have this string. It's a small s string, and then the name of that variable. Let's say my name. No, sorry. This is supposed to be a capital S. So final string. So you have the final keyword, and then this is the data type. That is, so it can be a string, it can be an integer, it can be a bool, it can be all those data types. So this is final string, and then you give it the name. So let's say my school. School. How do you spell school? Yeah, in my school. So first thing is the final. Second thing is the data type. That thing is the name of that variable that you want, and then you have the equal sign. So the equal sign here is for assigning. So whatever I will write next will be assigned to this variable. This variable is like an address to some memory location. Like this my school will hold the value that I'm going to provide it, and it must be of type string. And yeah, so let me do it. So the way we initialize strings is using quotes. So I'll have quotes, then I'll give the name of the school, that is, let's say Embu, University of Embu, UO Embu, like that. You recall we said that every statement is ended by a semicolon, like that. This is simply how we assign, this is how we write variables and directly assign them values in that. So first thing is the final keyword. The second thing is the data type, that is the int or the string or the bool or any data type that you want. And then the name of that variable, and then the value. You assign it using the equal sign. Yeah, simple, right? Yeah, so and then it is saying here that we have some error. It's not an error as such, but it's telling me that the value of the local variable my school is not used. Okay. Don't worry about that. So if you want to see or if you want to see the output of whatever is stored in any variable, you use the print keyword. So there is the print, and then you have the parentheses, and then inside this you give the name of that variable that you want to print. So in our case, this is my school, so I'll just type in my school over here like that, and then don't forget the semicolon, like that. So what we have done here, first of all, we have said that every code must run inside the void main, and then so inside our void main we have this final string, my school, and then we have assigned it to this UOMBO name, and then we want to print it now to our to get the output or to see what is saved inside here. So I'll just come here. There are many ways to run this. So I'll just have this. If you're using VS Code, you'll just see this run over here, or you just come here up and run, start debugging, or run without debugging. So I'll just run it like that, and yeah, you'll see some UMBO printed over here. This means that if you want to access this value, you just have to print the variable name, that is my school. And then, so this is a string. We can create another variable over here, and we'll have final. And instead of string, we'll use int. Int stands for integer. That is the numbers that we have. Whole numbers, I mean, they should not be decimal numbers. Int stands for whole numbers. We'll have int my age. Let's say my age, like that, and then is equals to. And since we have declare the type as int, you'll have to give an integer here. So when I try to give something like a string like that, and then I terminate with a semicolon, it will give me some error. A value of type string cannot be assigned to a variable of type int. You see, like this. So it already knows that this variable is of type int, so you cannot give a string. In our case, this was a string, that's why it accepted. So if you want this to run, okay, you'll just have some random integer. So my age, let's say 60. Okay. So and then if you want to see that, you'll just have a print statement over here, and then you print my age. Simple. So if I run this, you'll see you embo, and then in the next line you'll see 60 printed. And another thing is that we said, okay, no, let us just finish with the data types. So another data type is bool. And also, if you have interacted with another programming language, you know that bool only exists as only two values, either true or false. So you can have bool final. Bool is the keyword. This b with a small b. Bool. Let's say, is it raining? Is it raining? Is it raining? Like that. Okay, like something like, is it raining? Obviously, you know, it can be either a true or false thing or a statement. So bool exists as only true, just like that, or false. Just type in the whole word, either true or false. Yeah, so just come here and print it out. So is it raining? Then you terminate with a semicolon. So when you run this, you'll see here your embo printed for this, and then 60 printed for my age, and then false as a bool, which is here. When you change this to true, when you run this code, you'll see true printed out. Yeah, so this is the third data type. Another data type is, okay, let me check, double. So we said that int is for whole numbers only. So if I try to write, for example, this is 60, I write it as 60.6. This will give me some error. It will say a value of type double can't be assigned to a variable of type int. So int only takes in whole numbers. So if you want something that is a decimal, you use double. So we'll have final double, sorry, double pi is equals to 3.142, like that. So you can see this allows decimal places, I mean numbers with the decimal double data type. And then we can also print it out over here. So I'll do this first. Print pi, and then we'll terminate with a semicolon, and then I will run this. Yeah, you'll see it will print out 3.142. Yeah, there are some more data types in Dart. You will check them out, but I think these are like one of the most like 90% of the times, these are the most common data types. There is a data type, for example, called number, that is final num. Num is its keyword. My number, let's say, let's call it my number is equals to, what this num is, for instance, where you are expecting some number value, but you don't know if it will be an integer, or it will, I mean, if it will be a whole number or it will be a decimal number. So you just use num. It's like a combination of double and int. So as you can see, this can accept a full number 60, or it can accept a decimal number 3.142, anything, without giving any error. You see, so this is a data type called num. But if you're sure it will be a decimal, just use double. If you're sure it will be a whole number you just use int. Yeah. Okay, from there, I hope there is no question up to there. Let me check. Let me check the chat. Okay. Yeah. Thank you. So if you have any issue, you can just type it in the chat, and then we will go through it. Another thing is comments in that. So comments are like words that you put there, but uh, the compiler ignores them, and mostly they are helpful to document your code or to have like some heads up for about what a particular lines of code are doing. Comments are essential for code documentation and readability. They are ignored by the compiler and do not affect any program execution. And they are of two types. They are single line and multi-line. So what we are basically saying is that, for example, you want to give some explanation about this code, or you want to show what this code is doing, or you want to write down what this code is doing for either for someone else who will come to read your code, or also for your future self, because as you know, like humans, we just forget things out, you see. So to have some comments inside your code that will help you remember what you wrote down if you come to look at this code some days later. And by doing that, we have comments. And one thing about comments is that they are ignored by the that system. Like that does not look at comments. It does not check for any errors, the syntax errors or stuff. Neither does it do anything or any operations inside the comments. They are just for developers to help out document your code. Write a comment, you use 2 forward slashes like that. Then you can now write anything past this. Most probably, if you use an IDE, an environment like VS Code, anything you write here will be green in color. That is, this is a string like that. So these are comments. You see? So immediately you write these 2 forward slashes. Anything you write after that is ignored by the compiler, and it will exist just like this as a string. And you can have strings anywhere. So like this is a string, so that's a comment. And then maybe you want to comment that this is an integer, so you just have this like that. So this is an integer, integer. I'm sorry, for whole numbers. You see? So this is the whole point of having comments in your code. It helps you like document your code and maybe explain what this code is doing, maybe give some warning, like if someone is to edit this code, they should do this 1, 2, or 3 things. Yeah, so this is how comments are written. You just have these slashes, then you will write your comment after that. And again, the comments are ignored by the compiler. Yeah. The next thing is flow control. We use the if, the else, if, the and else for conditional branching, and also the switch. And we can also use these comparison operators. First of all, in that you can have normal operations. Like, for example, you can print something like 2 plus 3 like that. So 2 plus 3 is inside this print statement. So if I run this code, this 2 plus 3 operation will be done, and some output will be given. So let me run this, and you'll see 5. 5 is being printed. Okay, let me increase the size of this debug console. Just a minute. Debug. How do we do with this console font? Yeah, font size of the debug console. I'll make it 25. Yeah, I hope that is better now. So if you can see this is 5 being out. So what you call this plus is an operator. I think I can just comment this out. So you can, if you want to comment something out, you can just highlight it with your cursor, and then you have control and a slash, just like that. So everything will just be commented out. And as you can see, the compiler does not look at anything that is commented. So it will not alert me if I have written any variable and I have not used it anywhere. So we can have this. So I was talking about this operator. So for example, this plus is an operator. It performs an addition. You can also have another operator, that is the minus operator. Let's have a bigger number on the left. That is 10 minus 3. So if I run this, 7 will be the output. You can have the one, the multiplication. That is that one, the asterisk, I think. If I run this, you'll see 30 being the output. Another one is the division. Let's use 9 and 3. Sorry, I'll run this. They are basically normal operators, like we use them normally in mathematics. Yeah, so 9 divided by 3 gives us this 3. And what other operator? We have the greater than operator. So this equality, I mean these comparison operators, they return bool. That is, it's like you're asking, is 9 greater than 3? So the output can be either true or false. So I'll just run this and see here true. Why? Because 9 is obviously greater than 3. If I replace 9 with 1, which we know is less than 3, and run that, it will output false. This means 1 is not greater than 3. So this is a greater than operator. We can also likewise smaller than operator. Nice and easy. Yeah. So this will be true because 1 is less than 3. We can have less than or equal to. This is how we write less than or equal to. So you have less than or equal to. Just the way you pronounce them is the way you write them. So is less than or equal to 3. So if I run that, you see true. Why? Because 1 is less than or equal to 3. So if I have 3 over here, 3 is not less than 3, but it is equal to 3. So this will also be true. Yeah, perfect. Like that. But if, for instance, I have 4 and I run it, you'll see it will give us false, meaning 4 is not less than or equals to 3, because obviously we know 4 is greater than 3. Yeah, so those are mainly the common operators that we use in Dart, and also we'll see them in Flutter. Next, we have now the flow control. I think I will delete this. And inside our main function, we'll now have our control statements, and we'll start with if. So for this, we'll just use a simple example, like the one we are most commonly acquainted with, and that is a simple grading system. We will declare some variable here, final int student score, and then we'll give it some variable. I mean, we'll assign it some value. Let's say these are very bright students, so he has 90 in his marks. So we have declared we have declared some integer student score, and you have assigned this the value 90. And then over here we'll now have our control. So what you're basically doing is checking the grade of this student, and then printing the grade that those marks assigned fall. And we'll do it in this way. So if the student score is greater than, let's say, 80, and then like that. So this is how we this is how we write. This is a syntax for writing an if statement. So you start with the if keyword, and then you have these brackets, and then inside these brackets is the conditions that you are checking. We have looked at this operator, the greater than and equal to. I'm sorry for this. The greater than equal to any operation that you want, or any operator that you want to check against. This goes inside these brackets. And as we all know, the output of these operations is either true or false. So what happens is the operations inside here are checked, and if the result is true, the code that is inside this block gets executed. You see? So it's as simple as just checking this, what is inside here, and if it is true, anything inside here starts running. So in our case, we have this student score. We had written it down here as 90, and then we are checking, and the operation that you're doing is checking if it is greater than 80. And if that is true, what we'll do is just print something. So let's print a string and say bright student or excellent. Excellent. I hope it is spelled like that. You see? So this is a simple if statement that checks if this variable, the value assigned to this variable is greater than this 80. And then if that is true, this is executed. And else, I mean, if it is not true, nothing happens for now. Okay. So this, you'll see excellent. Excellent is printed. Why? Because 90 is greater than 80. And why are we using 90? Because it is the one that we assign to the student score variable. So deep down, like, okay, not deep down, but we know that this student score, the moment this student score reaches here, its value is 90 because we have assigned it here. So it's like saying, it's like asking that is 90 greater than 80? Of course, it is greater than 80. So what does it do? It executes the code inside these braces. And what is that code? Print excellent. And excellent is printed. Simple. So what if you get something like 70? We assign this student code to 70. We all know that 70 is not greater than 80. So if we run this, yeah, you can see nothing is printed, nothing happens. Like the code just exits with no output. Why? Because 70 is not greater than 80. So what we do if we want to do something based on the false outcome? Because we have said these braces handle a true outcome. Anything that is true is handled inside this. So what do we do if we want to handle the false outcome of this evaluation over here? We use the else keyword, and the else, after else, you just open another block of code in this parenthesis. So if this operation returns false, we'll use this else statement, and anything that you print, anything that you do inside here will be, any code that you write inside here will be executed. In our case, let's print something. So if a student has something greater than 80, we'll print excellent. Else, we'll print not bad, try again, like that. So we are basically checking, is this greater than 80? If it returns true, print excellent. If it returns false, print not bad, try again. So let's run this. Not bad, try again. You can see that not bad, try again is printed. This means that the condition inside here was not met. This print excellent was not executed, but instead this print not bad again was executed, because we have said again, if the condition is true, anything inside this block of code gets executed, and if the output here is false, anything inside this else block of code, I mean, is executed. Yeah, so I hope that is clear up to that point. Another thing that I might want to include is if you have steps, like let's say you have a couple conditions that you want to check on this specific variable. So in our case, for this example, let's make a simple grading system. So if someone has greater than 80, we'll print you have grade A. Sorry, grade A. Then what if now you want, like if someone has between 80, between 70 and 80, you want them to have grade B, then 60 to 70 grade C, like that. So you can combine else with if. Yeah, you can combine else with if in a very simple way. So in our case, at the end of the first block of block of code, you have else if, and and when you write this, you have your parentheses again, and then you have your block of code, just like that. Simple. So let me minimize this a little bit so that the whole code is visible. So what we are saying is you have this first condition check, that is student score is greater than 80, and then print is executed. Then else if, now inside this parenthesis you write the second check, that is you have said student score is greater than 70. We want something in between. So if student score is greater than 70, and okay, the way to do and is you use this is it called an ampersand? Yeah, double ampersand sign, the one we normally use for and. That is, so you have two conditions. So if you want something between 70 and 80, of course you have it must be greater than 70 and less than 80. So you have student score less than 80. You see, so then you open now your curly braces. So the condition that is in between this will be executed here. So we'll print you have grade B, like that, and then I'll terminate this with a semicolon. You see, so first thing, it is checking against 80. If that is true, you have grade A, then else, and then you add another if, and then these are the conditions that you are checking. And the first condition is student score greater than 70? Yeah. Is it less than 80? Because if it is greater than 70 and also greater than 80, it will be printed inside the inside this greater than 80 bracket. So use this double ampersand to mean and. So you check these two conditions. If that number falls in between 70 and 80, you have grade B. Okay, and you can do that like another time. It's not like limited to only one time. So you can have else if. So I'll quickly, let me just copy this. Just copy and paste it inside here. So if student score is greater than 60 and less than 70, then I will open my braces where the code for that condition returning true will be executed. That is print. You have, this should be a string, so you should have it inside quotes. So you have grade C, yeah, and then I will terminate it with a semicolon. And then, okay, you can have this repeating else for all the conditions that you want, but in our case, I will just end it here because of, also because of time. Yeah, So you have grade C, and then else gets executed if none of these conditions are met. You see? So if that score is not greater than 80, not between 70 and 80, not between 60 and 70, that is 59 and below, that is when this else statement will be printed. So we'll just say, we'll just print you are a failure. This is so cruel, though. Failure. I'm sorry. Failure. Failure. Is this the real spelling of failure? I hope I'm not also a failure. Yeah, like that. So you see, this is how we write an if, else if, and an else statement. So I'll just run this quickly. And the output is you are a failure. I don't know why it is printing this. If score is greater than 80, else if score is greater than 70 and less than 80. So this is 70. So this is if the score is greater than 60 and less than 70. Oh, okay, I forgot to add equal sign. Is greater or equal. Remember, we are checking also for 70 itself, not greater. That is not 71 and above. So we have to include greater than or equal to. And also here, sorry, like that. So I'll just run it again. And it will say you have grade B, just like this. Why? Because our student score holds a value of 70, and 70 will return true if we check against this condition. That is, 70 is greater than or equal to 70. So if we have another value like 65 quickly, so we expect it to fall between this grade C. So let's run it and see. Yeah, you can see it prints you have grade C. And then if we have any other value like below this, for instance, let's have 40 and run this, you are a failure. So this executes after all these checks are done and none of those conditions are true. That is when the else statement is executed, like that. Yeah. Any questions? I'll be glad to answer. Okay, so what is the purpose of the function final? What is the purpose of the function final? Okay, so final is not a function. Final is just a keyword to specify that once this value has been assigned, you cannot reassign it again. Like this student score has been assigned to number 40. So I cannot come here and say final or yeah, final student score, student final int, let's do int student score. Student score is equals to 90. You see, the error will be the name student score is already defined. Try renaming one of the declarations. So you cannot declare this student score again once it's final. So final is not a function, it's just a keyword to show that this variable, you have assigned it a value, and that's it. That's it. Like you cannot do the reassigning again. Later on, you'll see how to initialize variables without giving them the final nature, because in Flutter, for example, there are some values that you don't know. There are some variables that you don't know their values. That, like, their values depend on some operations down the line of code. Let's say your app is talking to an external API and then fetching some details and then assigning them to the values. You don't know the value of that variable when you are writing the code. So you don't have to make it final like that. Final is omitted in that case because, and as you can see now, you can leave this assignment because you don't know the 40. And okay, it will bring some issues down here because